there are going to be different use cases where I would almost expect LLMs to be there, kind of do things on its own. In certain cases where your tolerance for error is low, you may want to couple it with kind of the hybrid deterministic kind of things. And then in certain cases where the tolerance is really low, you'll also want to couple it with the human. So that is the framework. At the bottom layer, kind of I would say kind of the most kind of where we want human supervision. Then kind of comes kind of your hybrid legacy NLU plus the Gen AI based kind of intent understanding, and at the top layer is kind of the fully kind of where there is no legacy or no kind of traditional NLU, no human. The Gen AI kind of thing is good and so on.
Atul Deo, welcome to the Voicebot podcast.
Hey, Brett, thanks for having me here.
I'm really happy to have you here. Like, so timely, right? We've got a lot of announcements you've just made. We've got reInvent coming up. I'm sure you'll have more. And obviously, we have a rare confluence of new technology excitement around generative AI. So it seems like the perfect time to talk.
Absolutely.
Okay, so tell us a little bit about what you do just to get started in case people don't know who you are.
Sure. So, everyone, my name is Atul Deo. I'm the general manager for Amazon Bedrock. I lead product and engineering for the service. I've been with Amazon for 9 years, and as part of this past few years, I've had the chance to work on a bunch of different services, including launching Amazon Transcribe, launching numerous AI capabilities for Amazon Connect, which is our contact center service. And also Amazon Code Whisperer, which is our ML-powered code generation service, which is in fact one of our first plays in generative AI.
Oh, so I didn't realize that you had worked on Code Whisperer.
Correct. That was before the term generative AI actually became rampant.
It is pretty interesting. So, in words matter, right? You know, in markets, because I think people need something to rally around.
Right.
And generative AI really picked up around, was starting to get a lot of currency around a year ago, right now, even actually before ChatGPT. But then everyone just sort of adopted it, and I think it's always interesting to see how those things play out.
Right. I really think last December. I mean, I've been working in this particular kind of area for at least 2.5 years now. But really, I think last December was when I thought kind of it became more kind of well understood, and the excitement and the interest in it soared quite a bit. So
Got it. But you said you worked on Amazon Transcribe as well. So
Correct.
that's I think that's going to be interesting to a lot of people here, because a lot of people understand sort of who listen to this podcast understand transcription. It would be really interesting to me to hear your perspective on the transcription market and some of the other tools, whether it could be to connect as well, and the way people are thinking about that versus the way they're thinking about generative AI now, because it was, you know, it was a very useful tool set at one point, but there wasn't this sort of level of excitement for sure. And people weren't thinking that it was going to sort of change the way they think about all their applications.
All right. So I think just I know we're going to focus a lot on Bedrock and generative AI here, but I do think transcribe and just in general ASR, taking kind of speech converting into text, I think remains a very important customer problem, generative AI or not. Because at the end of the day, we do a lot of our intelligence based on the written text, and the spoken modality is just easier to kind of do. I mean, when we often, even in a contact center, we want to talk to someone, even if we are talking to a bot. I don't want to type; it's just convenient. But analysis is usually done on written text. It's easier for us as humans. We like to read and we like to think better when we see written content.
Yeah. Well, and this, we can talk about this as well. I mean, when you think about the work that you were doing in Amazon Connect, you know, again, we're talking about people speaking usually, or using natural language, sometimes typing, right? But using natural language to communicate. And I think that is the biggest part of this revolution by a significant margin.
Right. Absolutely. Yep. I think I'll just let me give a very quick overview of kind of what we did on the Connect front. Essentially, people would call contact centers, and people would have millions of hours of calls, and companies who would manage these contact centers would know have very little intelligence on kind of what are the customers actually calling about. They could be calling about they may have some positive feedback, they may have some critical feedback for their products, but it was hard to kind of really separate the signal from the noise, and even just kind of search for a magnitude of a particular known issue. And because we would transcribe them and make it very easy to search through historical calls and identify various issues, such as, hey, whether the agent is adhering to a particular training protocol, or whether they're adhering to certain compliance standards. So transcribing kind of input audio into text just enabled kind of unlocking of a lot of intelligence. And I think there is almost a natural relationship between that use case and kind of where generative AI today is as well. Because if you look at the last 5 6 years, one of the most kind of prominent kind of use case for AI has been contact centers.
Yes.
Because yes, so I do expect that as we kind of continue on the generative AI kind of journey, a lot of those same use cases that we have kind of companies have found a lot of value in, but they struggle to kind of find quick or kind of much better, richer answers. They will now have the ability to get better answers and better insights because of generative AI. But of course, the step of converting the audio into text remains, because a lot of these models today analyze text, and text is easier to analyze because you can look back for a longer period of time and kind of do interesting things with it.
Yeah, absolutely. So when we think about the the contact center in particular, this is one of the areas as well where we're thinking for large language models are going to have the biggest impact. And when you're working with Amazon Connect, you're working predominantly with NLU based systems, so NLP with an NLU model.
Correct.
And
Exactly.
and you have a technical background, so I don't know how much technical work you've done, but you have a technical background, so I know you understand these things. Why do you think it is, and I ask this question to everybody, why do you think it is that the large language models appear to be so much better at divining intent
Yeah.
without actually explicitly divining intent?
Oh, I'm so glad you asked that question. The distinction between NLP and NLU was significant if you asked anyone a few years ago, before the advent of large language models, right? Before NLP was kind of in some ways primitive to what we have today. It was sentiment analysis, entity extraction, kind of maybe relationship between entities. But really, kind of NLU, we used to say, was kind of this higher level abstraction where kind of there was some more understanding of the conversation. And it was in some ways, I would say it was largely it was a sophisticated way of hard coding it. And I think that was because the models themselves did not have very broad context. We did have models like BERT, which were pre-trained in the context of NLU, but they did not have the context of the entire internet, say. And today's large language models, they get trained on trillions of tokens. Tokens are essentially one token is about 3 to 4 characters. So just say
Right.
that they get trained on a lot of words, and because they get pre-trained on a lot of words, and they understand the relationships between kind of different words and kind of where they are, uh, they essentially come out kind of getting a better understanding of the real world than any models like that had 5 years ago. So because they do that, you basically have gotten rid of this concept of what used to be known as intents and slots, and someone having to painfully define those intents and then define a concept of a fallback intent. It's like, hey, if I don't have any of this, then you have to do something kind of a catch-all intent. So
Right.
anyway, so we are, I'm very very kind of happy kind of that interacting with chatbots, particularly in the context of contact centers, will be less painful now. Because before, some bot developer or chatbot developer would have to painfully specify all the intents and slots, and then ensure that they work, and then do rigorous testing, and every time there would be some upgrade, they would have to kind of make sure that it is all working again. And then the end customer experience would be frustrating, because real world people are not that rigid. Yeah, they tend to do many different things, and as I said, it is kind of predominantly kind of based on a very rigid framework. So that did not work. And now, kind of with large language models, we really are expecting that potential to be unleashed.
Yeah, absolutely. Really well said. I was at a conference in London a couple of months ago, and it was exclusively for conversation designers. And it's really interesting because it's changing their jobs significantly. Uh, and I have to say, a lot of enthusiasm about it, like some trepidation as well, because maybe there's some concern about like how central their role may have been, their roles changing, all
Right.
these other types of things. Uh, but the way that we used to do this, like from a designer standpoint, not just like from the technical standpoint, but from a designer standpoint, used to sort of figure out like what the optimal flow would be, like what is a
Mhm.
conversation, and then to think about like branching, like all the different types of conversations, all the different variants for that conversation, and then all the branches that could go into. And you can see quickly how that gets out of hand and that you get stuck with, as you talked about, sort of all these
Absolutely.
fallback intents.
Yep.
And so, I think that what I think is really great for, conversation designers, for example, is that now they'll actually be able to ply their trade much more effectively. Because what they're really good is designing these conversations, not designing every little nuanced variance of how someone might say something, which is really a limitation of the speech to text systems, which we were talking about just a
Right.
couple of minutes ago.
Yep.
Yeah.
Absolutely.
So, so I think it is fascinating too, and I've never heard a really good answer to it, other than like well, I should say I've never heard an answer that like sort of totally satisfied me with it, or about it. Is that the large language models are better at discovering intent, even though actually uh, they don't actually determine intent. Like they can be used afterwards as like an analysis
Right.
tool for that.
I think the way to think about that is simply someone who's read a lot of books. Kind of when you read a lot of books and understand them in context. Now, for the model to actually read a lot of books and understand the content in kind of relation to each other, that process, which we call as pre-training,
Yes.
essentially requires a lot of compute. It's a very compute intensive kind of process. Think about kind of us as humans, right? I mean, for us, I mean, I have a 5 and 7 year old, and essentially their journey for the next few years is now going to be reading. It's in some ways it's going to
Yes.
use a lot of compute, and with kind of cloud computing, essentially you have a chance to throw in a lot of compute at the problem and essentially accelerate the process of a machine being able to learn a lot of that context. Of course, we as humans can't just simply throw more compute. They have to go through that painful journey of actually reading. There's no parallelization there. I wish there were, but there's none. But at least machines can, and that is what is kind of unlocking this ability for the machines to get really good at understanding, and that's why they don't need to be programmed for every little thing. But I think there are some obvious challenges that come with it. As we all know, internet is not perfect. So this is kind of you almost produce this person that has read too many books and kind of can be a little too like he's just he's like too much of a bookworm in some ways. He just knows exactly, or the model just knows exactly what to say next.
Well, you said a lot of interesting things there. So I actually like the way you describe that. And what I think it's fairly obvious to people that because LLMs have been like these systems that have read a lot of books, for example, they've read a lot of books,
Yeah.
consumed a lot of different types of data, that they are really good at generating responses. I hadn't really thought about it in terms of like understanding what the response should be, right? Uh, so I think I think that's a really interesting concept, is this idea that, okay, so it read all these books, it understands what to say, but it also understands when you ask a question, what the context is around that.
Hmm.
Um, so I like the way that you've characterized that. And I don't really hear a lot of people talking about it. Everyone just says, well, it's just trained on a lot of data. So that's why I keep
Right.
asking people, because I always want to see if there's like a
Yeah.
better answer out there. But I like that. I think that's a really good contextualization. So let's talk about Bedrock. So Amazon announced Bedrock, I think, in April. Um, and I've been aware of Amazon's large language model for some time. I know this predated April. It had been around. It was sort of like secret. People internally within the organization could use it sometimes, and all these other types of things. But it was a real product out there. But when you came out to market, you didn't just say, okay, Google's got Palm, Microsoft now has OpenAI, we have Titan. You said, no, what we do is we have a service. It's essentially a model garden where people can choose. And here are 4. Titan's one of them, but then I guess you had 2 other LLMs and then you had Stable Diffusion for image generation. When did that strategy come together?
So I think before I answer that specific question, let me zoom out a little bit, right? If you look at even machine learning in its early days, we look at history a lot just because there are past things repeat in patterns. Whenever a technology is nascent, things are kind of changing a lot. For example, in the early days, TensorFlow was very popular, and now kind of obviously there was a bunch of other frameworks as well, Cafe and things like that. And our approach at that time was, we are going to support it all. And over time, of course, PyTorch became big. But in the early days, it is not very clear as kind of what would actually happen. And our approach was, of course, we should develop our own 1P models for various reasons, and I can cover kind of why we need to invest and why Amazon is investing in our 1P models, which we call as Titan. But for us, most importantly, it was about giving customers choice. One thing we've always done as AWS, right from the early days of machine learning and in general across the board, across our portfolio of services. So that was the plan. Of course, I would not, the first step, the harder part for us was to kind of start on the model development journey. And as we went along that journey, we quickly kind of realized that, hey, we also had to think about customers because the space is new and things are going to be different over time. So we cannot just say only customers, you only have to use Titan models, otherwise you can't use any other model. That approach did not resonate with us.
Yeah, absolutely. Well, so when you use the term 1P, just in case people aren't familiar with that, first party, so it's built in-house versus 3P, which might come out, that's third party. So like all of your partners. But just like talk about this. So why is it important? Is you're giving all the users choice, like you want to give them choice. Why is it important for them, one of those choices, to be from Amazon?
Sure. So let me explain both sides of the coin. I think it's important to understand why we are investing in our first party models Titan, and then I'll also discuss kind of why do we offer third party models or models from our partners when someone could technically go and use them on the respective kind of sites. For example, someone can go to Anthropic.com or Cohere.com and just use those models there. So on the first one, why we are investing in Amazon 1P models, there are at least 2 core reasons that come to mind. The first one is Amazon and AWS, we're very customer obsessed. For us, if there are certain issues related to the model, for example, say accuracy, right? And let's just assume that for whatever reason, the model is not picking up the intent despite kind of it being properly trained. For us, if that happens and customer comes to us and says, hey, I've been really trying to deploy this customer service chatbot, but I keep running into these issues. If we did not have our 1P or our one first party model, we would have to go and depend solely on a partner and basically say, hey, customer, kind of talk to the partner because we didn't build a model. When we actually build a model from scratch, we have a chance to go roll up our sleeves and actually fix that issue ourselves, which I think is something very Amazonian. The second issue is related to responsible AI. Now, obviously, responsible AI is a very important topic in general in machine learning and also more so in generative AI. And here, we want to make sure that we understand what goes into training of these models. So every single kind of piece of content that goes into training of these models gets thoroughly vetted by all our internal teams, including my friends in Amazon Legal. And essentially that gives us kind of good confidence and understanding of what has actually gone into training of these models, and we are making the right decisions on behalf of the customer. So those are the 2 main reasons why we build our own kind of one party internal models. The second one is around now the flip side of the question, as I said earlier, I framed it earlier, which is Why do we have third-party models? Now, it's obviously choice is a very important part of it. We don't want to just restrict companies to only Titans models. There are awesome models. There is not going to be one model that is going to be the best model for everything. Customers will have different use cases, and they will want to go use different models for different things. And even within one kind of use case, customers tend to use different models, right? Because sometimes they get combination. But essentially, these models are hosted on AWS, so and they're available as part of the same API. So the customer using, let's say, Anthropic's Claude is not going to anthropic.com to use these models. These models are hosted on AWS infrastructure, and they're available through the Bedrock API. A single API where a developer can simply switch across different models. And particularly in generative AI, where we are in such early stages that customers are experimenting a lot. They are trying to see which model is giving them the right combination of accuracy, latency, cost, and other performance characteristics, and for their particular use case. And they often tend to experiment with different models, and just having kind of this option of just a single serverless API where they don't have to deal with the underlying infrastructure. They don't have to understand any nuances of machine learning. Simply kind of mention the name of the model, including potentially their customized model that they created on Bedrock, and they can just experiment and create their application. So that for us, customers find it very empowering.
So you don't subscribe to AWS to the one model to rule them all.
Correct. That is not our approach. Yes.
Yeah. And I think that's interesting. It's also consistent with the way Jeff Bezos presented Alexa to the world. He always said, "Hey, we think there's going to be a lot of voice assistants out there. We have Alexa. We think it's great, but we fully expect there will be others." And that sort of went back to the voice interoperability initiative. I think that Amazon was part of founding, sort of maybe the driving force behind that. So, I think in some ways, like, this is just consistent with the way you've approached other technologies as well.
Right.
Yeah. All right. So when we think about we think about 1P versus 3P, like, how do you decide when you're going to bring a 3P in, which 3Ps are, have the right set of capabilities that are going to be good for an AWS customer?
Right. So usually, I think it boils down to a set of capabilities and what do customers want, right? So customers, each model kind of has, I would say, each provider or a model in our view has some differentiated or unique characteristics they bring. For example, with Anthropic, they have incredibly long context size, which is something customers care about. They are very well regarded on responsible AI, things like trust and safety, and things like that. At the same time, some customers want to deal with an open source model, and that's why we announced support for Llama 2, which is the industry-leading open source model today. So there are always going to be some nuances and certain gaps in our portfolio that will arise from time to time. And we will make a decision based on customer feedback and the comprehensive set of capabilities that will be offered as part of AWS.
I'm glad you brought up open source, because there was an announcement, I think this was pre-Bedrock, that Hugging Face had done a deal with AWS to put foundation models on AWS. And I think some people were surprised that it was not mentioned, Hugging Face, whether it's Bloom or the other models, other open source models that it helps to distribute, wasn't mentioned as part of Bedrock. Is there a reason for that?
So let me explain. So within AWS, again, as it goes back to our tenet, there is no one size fits all approach for all customers, right? So we offer different services and different capabilities for different set of customers. So for customers that are experts in machine learning, they want to get down into the specifics of the model, such as they want to access the model weights, they want to completely change the architecture of the model. That audience typically, like, think of like a data scientist or a machine learning expert. That audience typically uses our say Amazon SageMaker offering, which is the industry leading ML platform. And here we have a specific sub capability called as SageMaker Jumpstart, where we have a bunch of open source models, and including we also make accessible the Hugging Face set of models. Now, when customers do this, the key difference is that they have to manage their own infrastructure. It is not a fully managed service like Bedrock is, where customers don't have to think about underlying resources. They only pay for what they use. It's very consumption, like very, for example, it's based on per 1,000 tokens. Like I don't have to think about what underlying instance and how many hours of the instance I'm using it for and whatnot. And at the same time, kind of in Bedrock, kind of the controls are there, but their controls are not for a machine learning expert. They're more for a developer who's focused on building their app. They are not trying to tinker with the model in unusual ways. We support customization, but we're not trying to cater to data scientists who want to change the architecture of the model itself. And particularly in case of a lot of these non-open source models or proprietary models from providers like Anthropic or even Titan, which is our first-party model, the actual model details and the weights are not available. They're abstracted away from the customer, so it doesn't make sense to make sense for the ML expert audience, anyways.
Okay, that's a really great clarification. I appreciate you said that. So the model weights, if you're using your own open source model or proprietary model, you might have access to those, but in this case, you do not,
Correct.
because the audience that's using Bedrock doesn't need that.
Correct.
Okay,
Yep.
yeah, that's a really interesting insight there. I'm glad, because I don't think that was clear to a lot of people. Like people kept asking me, like, why is this not there? Why is that not there? And I think that makes sense. This idea of a managed service, because, and we've seen that too, spinning up your own large language model, just like in the AWS environment, that's not Bedrock. Actually, there's some work to be done, and it can take some time. There's some expertise there if you haven't done it before.
Correct.
And it can be actually quite expensive because it's not just metered based, because you have to reserve resources and things like that.
Correct.
So going back to Connect, when you think about Connect and taking an NLU based system and adding an LLM, is Connect adding Titan? Is it bring your own? Like, how are you thinking about that?
So I don't want to say more on this, because you will probably hear more about it in the coming weeks about Connect's innovations. But almost every service across Amazon is thinking about generative AI, and they are all trying to transform their customer experience based on generative AI. So I think this is one of the most kind of profound and core technologies that has come in the last few years. And I think everybody sees the potential, both internally and externally. So I would expect a number of new applications that will get built using this from AWS and Amazon, but also even the existing services, and even at the lowest not just kind of a higher level application like Connect, but even we are exploring how we can transform some of our underlying services or the infrastructure, the building block services, in whether they be customer facing directly or not, but even things like making better kind of operations, or kind of being smart about certain choices on how we do engineering for certain things based on generative AI.
So when we think about, I want to stick with Connect here for just a moment. So I understand, like, sort of no answer today, but maybe in the future around sort of a preferred LLM for Connect. Since you were part of that group, I mean, is your expectation that the customer support systems all become predominantly LLM based, hybrid NLU LLM? They just everyone turns them into a knowledge management system with a RAG in the back end?
That's a great question. So one thing I want to clarify what you said. I don't think with something like a Connect, we would expose the concept of an LLM. The LLM is like the means to the end, right? Whereas it's an application. So what you really want to focus is on the end. And the end is kind of customer support and kind of related things, how you can improve those set of workflows. And now specifically, whether your question was whether this would be completely LLM based or whether it is going to be a hybrid. I think the state of LLM, now you're getting to kind of what is the true state of LLM. For certain things, I think there are going to be different use cases where I would almost expect LLMs to be there, kind of do things on its own. In certain cases where your tolerance for error is low, you may want to couple it with kind of the hybrid deterministic kind of things. And then in certain cases where the tolerance is really low, you'll also want to couple it with the human. So that is the framework. At the bottom layer, kind of I would say kind of the most kind of where we want human supervision. Then kind of comes kind of your hybrid legacy NLU plus the GenAI based kind of intent understanding, and at the top layer is kind of the fully kind of where there is no legacy or no kind of traditional NLU, no human. The GenAI kind of thing is good and so on. But I think today it's going to be mostly a pyramid where I think a smaller set of use cases are going to be fully autonomous, and that's just we're super early in this space right now, but it's changing fast. And there are increasingly this pyramid is probably going to be more like an inverted pyramid over time, where you'd increasingly see more use cases come at the top, where the large language model or the foundational model is powering kind of most of the use cases in combination with things like agents. But yeah, that's basically how we see the world.
Yeah. And so when we talk about this idea of hybrid systems, which seem very attractive, and I know some people have done some deployment on that side, like retrofitting older systems, conceiving new systems. This idea of having both an NLU and LLM together,
Yeah,
basically requires that you have orchestration or some sort of arbitration at the beginning part of the process. Have you, I know like you have other things you do in a day-to-day basis, but have you thought about this a lot in terms of the architecture?
yeah. So I think there are different ways of solving that, and different customers have taken different approaches. One is kind of, hey, you can kind of keep, if somebody has already invested in the traditional kind of, let's just say Amazon Lex based chatbot, right? In the past, where kind of your fallback intent, where kind of if none of the customer kind of recurrence falls neatly into one of the pre-specified intents, you get routed to a fallback intent. And there, I think if it gets routed to a fallback intent, then you can have a large language model address that and kind of deal with it. So that is the one kind of simple abstraction or kind of approach that I have seen some customers take, and it's worked pretty well for some of them.
Yeah. So NLU first.
NLU first, and then go with again, that would be probably a more safer kind of journey for customers where they have an existing system and they've already invested. Of course, you don't want to just kind of rip and replace completely in some cases right away. And some customers, when you're building new applications, they may want to take down that path. But for someone who has a relatively, they have invested probably several years, and it looks like you have friends who have done this for a living. I think in that case, in those cases, I think we do think that there is going to be that journey. And I think, as I said, over time, that ratio will flip. You'll see more applications being developed from the ground up, which is purely kind of LLM powered, versus kind of morphing the legacy or the older kind of intent slot based approach and just relying upon a fallback intent for powered by the LLM.
Yeah, fair enough. Let's talk about Anthropic for a moment. So big news a few weeks ago, Amazon investing up to $4 billion in Anthropic. I think it was sort of misread as definitely $4 billion. I think so far it's been a few $100 million, but I think there's a lot of things. We peel back the onion: minority stake, what's their actual valuation, all those fun things that people like to think about. But you have your own large language model. You've got partners who are already in there. You could at the time set up Anthropic, but through SageMaker, but it was difficult. Why did, and this is not just a Bedrock thing, I think it's like broader, for AWS, but we can talk about that. Why Anthropic? Like, why was that the play?
So I think it's a combination of factors. Anthropic, as I said, Anthropic is a unique startup. We have been engaged with them for a long time now. Their models are some of the best models in the industry. We've been really impressed with the team. We really kind of appreciate kind of their models. And by the way, their models have been on Bedrock for now a few months now, even before the
Okay.
investment. So we've had enough kind of customers using these models and giving us feedback. And even internally, we have used the cloud models quite a bit for various things. And I think they are, as I said, they have some amazing characteristics on the models, particularly long context lengths. They are incredibly good on responsible AI, and they are innovating fast. And I think we from time to time Amazon makes investment decisions in various companies, and they're also a strategic customer. They are going to develop their next set of models using Amazon infrastructure, particularly Trainium.
Yeah. Okay. So like perfect segue. So Amazon CEO Andy Jassy in the last earnings call went into some detail about Amazon's generative AI strategy, and he laid out 3 layers:
Yeah.
infrastructure, foundation models, and applications. And uh, infrastructure was really an interesting highlight there, and I think it relates directly, as you suggested, to the deal with Anthropic. So they, part of that deal, they announced they are going to be running all their training on the Trainium chips, which are ASIC chips, not GPUs. And I think actually all the workloads are going to be run on Inferentia, correct? Which is the runtime chip, right?
The inference chip, correct.
Yeah.
Yeah.
So tell me a little bit about first, just about that, and you know, when did you start first investing in those chips? Like, what was the motivation behind that? Is it like a similar strategy as what you're thinking about from the LLMs? Or
Sure. So let me just rewind a little bit. So we've been investing in custom silicon chips for almost 10 years now. But I recall kind of my first foray. I joined Amazon in 2014, and in 2015, early 2015, we had just acquired Annapurna Labs. Now
right,
this is the company that is kind of the driving the development of these chips. This is a highly innovative company, and the original when we acquired Annapurna, they were focused on chips which were core to our infrastructure business, specifically compute, storage, networking. And over time, as we saw the strategic advantages that investing at the chip layer or the core kind of chip layer gave us in terms of differentiation from various aspects, in terms of better performance, reliability, and whatnot. We started investing in machine learning focused chips, and this was around I think 2017 2018 timeframe. Or actually even sooner. I now my memory is blurring, but I think roughly around that time frame. And now the good thing is that that decision turned out to be an important one, and particularly so doing it so many years before the advent of generative AI, because the having custom silicon chips is probably even more strategic now in the generative AI world, because our reliance upon compute to train these large models, as we discussed earlier, it's models trying to basically understand a lot of data, and doing that in a fast manner requires you to throw a lot of compute at it. And these models are getting better and better, and they're getting more and more data hungry, and that trend will likely continue. So for us, having the ultimately, it's kind of giving customers choice today. Even customers have only one choice in the market, and with investing in our own chips, customers get the choice to use the same set of technologies that we would use for creating our own models, but they can now make use of those underlying infrastructure innovations for creating their set of models and powering them for inference.
right. Well, so, and I think it's, I don't know if this is the term you would use, but like access to NVIDIA A100 and H100 GPUs right now is rationed because there's scarcity in the market. You can't just, and I've seen engineers like go on to AWS and just think they're going to spin up some NVIDIA GPUs for their AI workloads. And it's like, no, you have to talk to somebody in order to get access to it. So I think that's an important consideration here, because one of the things that I think seems awfully important is just having capacity.
Yeah, absolutely. I think particularly in the Gen AI world right now, that there is enormous demand, not just from model builders like Anthropic, who are actually training really large models with a lot of data, but also for inference, because once these models are built, customers are very hungry to start using them. And inference on these also tends to be you need very high performance chips to deliver the right combination of accuracy, latency, and cost.
When I was talking to a startup founder just recently, and he's using AWS, he has a fairly successful sort of interactive entertainment style bots, based on LLMs. It's not character AI, but it's one of the other players out there that people might be familiar with. And he said it's very difficult when they do a product launch or like a new announcement, because there is not he has to forecast how many, if he's going to run on NVIDIA GPUs, he has to forecast how many he has so that they're available. Otherwise, he can't scale up. So it's not like a truly elastic model. And so my question for you is, with, when we think about Inferentia, the Amazon chip, is that also rationed? Is there a limit to those, or is it pretty much if you need Inferentia workloads, you can get them immediately?
I don't have the answer on Inferentia. It's not. I don't. That's not kind of something I know. Unfortunately, I don't want to give you a wrong answer.
Okay. Yeah. Fair enough. Yeah. Okay. But I think that's a big part of it, though, right? I mean, this idea that we have, everyone talks about training. Yes, training. But okay, so if your training gets put off by a couple of days, it probably doesn't ruin your whole year. But if you can't actually meet an SLA for an application you have that has to run inference, then that could be really devastating to a business.
Well, what I can tell you, though, is if you use Bedrock, because you are basically running the model, you're creating your application, you can reliably go into production, because whether it's under the hood, kind of that infrastructure is abstracted away. The customer doesn't have to worry about availability and whether there will be kind of enough compute to kind of manage their kind of end production usage. There is no rationing there, so their customers can kind of run safely into production. Of course, there we offer different models, and particularly there is an on-demand mode where someone can just pay on per 1,000 token basis, and then there is a provision throughput mode where you can basically provision sufficient kind of model units to ensure that you can deliver performance. Let's say you're expecting 1 million plus customers for a sustained period of time. You want to ensure that there is no kind of performance degradation when that happens. So you can essentially ensure that you have enough kind of capacity and whatnot lined up for that.
Got it. And so in that case with Bedrock, you do allow customers to reserve capacity.
It's not really capacity. We do the capacity management on behalf of customer. The customer simply says, hey, I want X number of model units for this period. So they just basically buy those model units. And under the hood, we will basically figure out kind of what is the capacity required to deliver that expected performance that a customer has asked for.
Okay. So when someone's using Bedrock, do they choose the infrastructure, or do they just choose the model and then Bedrock
just choose the model?
Determines?
Correct.
And so do the models have different SLAs in terms of latency?
So the models do have different, I would not say SLA, we don't, but they do. Every model has different expected latency associated with it. For example, a Claude Instant, as the name suggests, is going to be a much faster model than a Claude V2, which is the most performant model. And in general, I think that's the norm we are seeing in the industry, where almost there are two kind of main models from most providers. One is like this very capable model on one end, and on the other end there is this smaller, high performance, high speed model.
The other thing I've seen just in terms of model variants from some of the different foundation model providers is they seem to all be biasing towards instruct models as opposed to other type of base models. Is that because the primary use cases right now are some sort of chat interface?
Correct. So instruction tuning, just for listeners who may not understand, kind of there are various. These are all various stages of model development. So as someone like who's building a model, they will first start with the process of pre-training. So you just basically throw. I'm going to simplify this process. I'm going to oversimplify this description, so scientists please don't get offended. But essentially, you throw a lot of data, cleaned up data. You throw a lot of compute and you throw in algorithms, and you get this pre-trained stage. And then after that, you apply various layers, and it includes your instruction tuning, and then something known as supervised fine tuning, and then you apply what is known as reinforcement learning with human feedback. And essentially, you're updating the model's weights based on the subsequent layers of training. So the pre-trained models are great, but essentially you're making the models even better, and you're training them to deal with certain types of, you're optimizing them for a few things. So conversational ability is one such characteristic that typically you would see that the models get better after the instruction tuning. Classic example being, hey, Llama 2, for example, has two variants. They have a pre-trained model in a particular size, and then they offer a fine-tuned model. It's just essentially instruction-tuned model that can then do better conversations. So, but that is not the only use of. I think being good at conversations is one aspect. They can also be used for various other things, such as, hey, particular type of prompts. Essentially, the model can be trained to say, I'm not going to answer that type of question. For example, somebody is asking an opinion on healthcare matters or a medical condition, and you can basically apply certain type of fine tuning to say, hey, I'm not going to talk about it.
When we think about the model adoption right now, you mentioned Anthropic. It has some very specific characteristics in terms of the large context window, 100,000 tokens, roughly 75,000 words, I think. And GPT-4, it's got 32,000, but like most people don't even have access to that. It's not really an offering that is out there in the field. Most of the context windows are going to be between 4 and 12,000 tokens, so much smaller. So that's like one difference, right? So context window, it's like very obvious. And Anthropic, kudos to them, because they were able to do large context window and relatively low latency, which we haven't seen in the past. What are some of the things that you think are interesting that differentiate the other models?
Sure. So I think for example, stability AI's models are in a completely different realm, right?
Yes.
They are focused on image generation. I don't think we have. Anthropic so far has focused completely on text. So that's a gap. AI21, they are an Israeli startup, and they are very good on multilingual performance, for example. And then Cohere's models are good on RAG. So RAG, or retrieval augmented generation, is a common workflow that customers do. And essentially, models are pre-trained, or they just understand general purpose information, but they don't really understand a company's proprietary information, and also information that is up to date. So essentially, as part of RAG, what happens is you feed the model, you pass latest information as part of the prompt, so that the model takes that into account and gives a better answer. So, or not just better, but a more relevant, accurate answer. And there are various optimizations that companies have to do to kind of get this kind of right. And Cohere has a very good embeddings model, which is used for RAG to generate the embeddings to do the matching. And then their Cohere command is optimized for RAG.
Yeah, got it. Well, and I think I just saw an announcement as well around Titan actually providing more features around custom embeddings for RAG.
So on Titan, what we recently announced as part of our on Bedrock GA announcement is we announced our Titan embeddings model, the text embeddings model, and that we also, it's the multilingual model on Titan embeddings. It has 8K context length, so you could pass significantly longer inputs for the embeddings model. It generates one and a half or 1.5K output dimensions, and it is a pretty nimble model for doing RAG use cases. So that is a model that customers often use in conjunction with even Anthropic's Claude, for example, because that is where the beauty of Bedrock, where we expect customers to combine models from different providers to do different things. So imagine a workflow where someone is using Titan embeddings to create the embeddings, store them in some vector database, and passing kind of queries to the Claude model. And then the Claude model's outputs can then be used as inputs to an image generator from Stability AI. So there are a lot of this kind of interesting permutation combinations that we expect will arise over time, particularly as we progress further into companies' maturity of their use cases and the kind of problems that they want to solve.
Yeah, I guess this goes back to there's not just one rule. There's not one model to rule them all for all use cases, but it's also within
Right.
a use case. Almost everybody's using multiple models for
Correct.
everything.
Correct. It's kind of the famous the proverb, right, or the phrase, best of breed and capabilities. It's kind of it's a combination of those. So you want kind of the right model, the right tool for the right job, and that job could entail many sub jobs. So you would find the right model for each of those sub jobs.
So we talked about a number of different things. I want to go back to Llama really quickly. So Llama 2 from Meta has become very important, very popular in terms of a solution in the market because open source. I think very permissive licensing, as long as you're not like the scale of TikTok or something like that. High quality and really like a relatively efficient model. I think that people are looking at and then in multiple formats too, right? So or multiple sizes that we can think about, and a lot of that is based on this idea that it's not just parameters anymore, right? So 2 years ago, seems
Yes.
like all we talked about was model parameters, right? And and then it was like the data set, the training data set was important, but the size of the training data set was not that interesting. So I think like Megatron was maybe the first one that did 1 trillion tokens, and everyone else was doing in the few 100 million for their largest models. Tell me what your thoughts are on that, what you've seen, because what seems to be more important now is that maybe we've reached a local optima on the number of parameters. And so right now it seems to be the amount of tokens used in training and the quality of that token set.
So you're absolutely right. So I think increasingly the focus is less on the parameter size; it's more on the capability and the quality of the model itself. And I think it's determined by a few factors. And there is actually, in fact, I would say that there are a few reasons why the parameter size doesn't matter or it's not reflective. Because there are different model architectures. You could go with a dense model architecture, or you could go with a sparse mixture of experts architecture, and it is not apples to apples. For example, you could have like a 2 trillion or a 5 trillion parameter model. In theory, I could have that, but if it is a dense architecture, you would require far less compute to train that than say a 200 billion parameter dense model. So it is not apples to apples. So ultimately it comes down to the model architecture, the quality of the data, how much data, and how much compute. So those are really kind of the key kind of, and of course the quality of the algorithms and whatnot kind of that goes into training of these models. So those are the key kind of parameters, or not just parameters, but no pun intended, the inputs that go into deciding kind of how good of a model it is.
Yeah. So you talked about a dense model. So a dense model, but you were referring to that not in terms of number of parameters. Are you saying
It's
that
the
like
architecture. It's the architecture. Correct. How are the layers kind of organized? So there is like the other end of that is something called as a mixture of experts, which is an example of a sparse model, right? So a sparse model can have. So if you have a given compute budget, you could develop say 100 million parameter dense model, or you could develop a 10 billion parameter sparse model, but they both take up the same compute and ultimately may have the same performance. But that's why the comparison of two models based purely on the parameter size is not helpful.
Okay. Yes, exactly. And that's what we're seeing right now is that we're seeing some smaller models in terms of parameters are outperforming larger
Correct.
models in terms of parameters. And a lot of that has to do with the training data.
Correct.
But the training data is not what determines dense or sparse, correct? Or it is because
Correct.
that's
You could use the no, yeah, correct. You could use the same training data in either architectures, but the
yeah.
quality and the quantity of training data does matter, regardless of the specific whether it's a dense or sparse model, right? So you do need high volume and high quality of training data. And in the past, there used to be this chinchilla scales. Google had published this paper called this famous paper called as chinchilla, right? So it basically said for X billion parameters, given a compute budget, this is the amount of training data in terms of tokens that you would need. But what something like a Llama 2 has essentially proved that the chinchillas, there are benefits to going way beyond the chinchilla scale. So they essentially used a lot more tokens than, let's say, a Llama's parameter size. The smallest model, let's say 13 billion parameters, or the largest is 70 billion parameters. They use
Mhm.
2 trillion tokens.
Right.
And as per chinchilla scale, I think it would have been far less number of tokens, which would have been predicted as the optimal number of tokens for that particular model size.
All the more reason why we need a lot of people in the market because different people find
Yes,
different innovation. Uh,
exactly,
and that
exactly.
like super important. And that's one of the things that I want to like get your perspective on that as well as open source in this space. Obviously, you're supporting some open source models. You are also supporting proprietary models. What is your perspective on the role of open source in generative AI, and how that's going to play out over time?
I think it is super early to talk about it because we're in such early stages of generative AI. But I think the innovations in open source have been very impressive in the last few months. Uh, Obviously, Llama, there is Falcon, and then there are a lot of kind of other kind of community-driven efforts to take some of these models and kind of add in other innovations, things like LoRa. There are so many interesting things that are happening where communities coming up with interesting ways to even take existing models and kind of transform them into something more powerful and capable. So I think we will continue to see the innovations in this space. And for us, kind of ultimately, whether it's open source or whether it's proprietary, we want to give customers kind of the right set of tools, and the choice, regardless of kind of how this space evolves, because ultimately customers will want the best and the best tool for their specific use case and needs.
Well, I'm hearing from some enterprises that they want their own model. Now, that's a two-edged sword because having your own model, it could be a pre-trained model, but they want basically to be able to control it, and not not rely on somebody else. It's always like tuning the weights and biases in it. Um, and if you do an open source model, uh, you're going to take on more work on yourself as an
Hmm.
organization because you have to become an expert in that as well. You don't have
Right.
necessarily like this army of people trying to make sure that that proprietary model is always working. Um, but at the same time, uh, they do get total control, and I I think part of it is like this idea that it's uncertain, so they're not sure who they should trust, like who they should put their stock in with. Uh, I think also part of it is uh, there's a lot of organizations that see this as potentially a competitive advantage, and they don't want to necessarily have their competitive advantage reliant on someone else's, I'll call it model in this case, not necessarily infrastructure. Um, any thoughts on that in terms of what you're seeing in the
Sure.
market along those lines?
So I think there are a few things happening here, right? I'm going to use Charlie Munger's kind of quote, or I don't know whether he used it from somebody else, but if you ask a barber whether he needs a haircut, the answer is going to be yes. Oftentimes, there are teams within companies where, historically, they have developed machine learning models, like just like they were conversation designers, and now there are teams that are used to being in complete control of their destiny, where they have developed a model from scratch. But I think in many cases, while I do think that there are some customers where that might make sense, in most cases, the model starting point is they want to be trained on the broader internet, or kind of broader kind of general. The model needs very broad understanding of the real world. And of course, then you can layer in your proprietary data. Your data is kind of your advantage for every company. That has been true for a long time now, and it will continue to be so in case of foundation models in generative AI. But I think the way to do it is you can take some of these existing models, whether they be open source models or whether they be proprietary models of your choice, and you can then layer in your proprietary data on top of that and create a differentiated experience. That is the approach that we think that will work for a lot of customers. Some small section of customers, for some reason, they may be in such unique kind of vertical that they expect to use majority of kind of data which coming from their own, right? But even in we haven't discussed customization in depth on this podcast episode today, but there are a lot of customization approaches in foundation models where you can skew the model towards a particular domain. So obviously we talk about fine tuning a lot. Fine tuning is usually for a particular task where you just provide a bunch of labeled input output pairs, right? For the the model to generate a summary of a particular kind. There are other approaches like continued pre-training, where I could provide, if I'm a financial services company, I might give it a lot of financial services documents, and I can skew the model in particularly for my company and my domain, and then that model can then be used across the company by different teams for specific use cases, and then they would do fine tuning on top of that. I think that's the direction in which some of those companies that are currently thinking that they would actually build from scratch, they will probably see that the latter approach is going to be way more cost effective and also efficient, because if they have certain teams and resources at their disposal, they would rather use them to create differentiated outputs than just kind of recreating kind of the base model, which a lot of you are going to be doing the work that a lot of competing kind of or very competent outfits like Anthropic are going to be doing, and they are going to be the experts at doing that.
Yeah, I'm glad you brought that up, because that was actually something I want to talk about in terms of this move to domain models, and we'll be wrapping up in just a moment. But so it seems like what we have is a lot of general purpose models out there right now. And so you go ahead and you can, and some of them you can change the embeddings. For all of them, you can do some sort of fine tuning in order to make it more appropriate for your application. So that all makes a lot of sense, I think, to people who are following this. But also, we're starting to see more and more of these domain specific models, which they're showing up being able to be used right away. I think about Google's MedPalm 2 is like one of them that's come out recently. And there's several in fact, actually, like ChatGPT Turbo, if like people are going to be familiar with that. I mean, that's a chat oriented version of GPT-3, right? So what is your view on that? Because you're a place, so it's like you're going to have everything, right? I think that's like your stated ambition. And so what does that look like to you going forward? Are we going to still see like all the focus and attention on a few foundation models that are general purpose? Or are we going to start seeing more and more of these models come out that are really domain specific, and that's where all the action is?
So first of all, I don't know. I would not call ChatGPT as a domain-specific model. I almost think of conversational ability as a table stakes capability of
Okay,
the
fair
core
enough.
base model. But I do think that there will be some instances, financial services, healthcare, security. Those are probably some areas where some companies will probably take an existing model and they will apply their proprietary data on top to create uh, kind of differentiated value for their customers. So we do expect that to happen. And again, my expectation is that they would not create the model from scratch. They would probably take one of the existing capable models and layer in things like domain adaptation on top, and tweak the model based on their proprietary data to create value for customers.
Yeah. And so, great point. And sort of we can wrap on this idea of how many models will there be? I mean, like we talked about this idea, we're going to use a lot of different models, but if you have a dozen models, which are very versatile, or maybe you have
Yeah.
24 because you have different variants and sizes of them, is that enough? Or should we start thinking about foundation models at some point getting to some specificity where essentially they're like applications, like they come in all these different flavors depending on what your business use case is?
So I would almost think of not the question as how many models, but essentially how many applications. And I think there are going to be a ton of applications that will be built on these models, and companies and customers who want to kind of create such experiences will go through the journey of taking one of these models that are, for example, available on Bedrock today, layer in their proprietary data, and then create a fine-tuned version, right, which is a variant, and ultimately use that to create an application layer experience that will abstract away that underlying model. So the number of models, that's why I'm like, I think it'll ultimately manifest as number of applications and not number of models on Bedrock. At least our goal would not be to flood it with models. As I said, our goal will be to offer kind of the common denominator of capabilities that customers would need, and then the customers should be able to take that and then layer in their unique data and their unique experiences for their customers.
Perfect. All right. Well, I'll let you leave this with anything that we missed that you wanted to talk about today.
No, I think you mentioned Andy's comments in the earnings call. I think we talked about. I just want to reiterate kind of the bottom layer, kind of that
Yes.
kind of investment strategy. We have the investments in our infrastructure. We talked about Trainium and Inferentia, which are our ML chips optimized for machine learning training and machine learning inference. At the middle layer, we have Bedrock, which essentially allows customers to you make use of foundation models and develop applications. Here today, Bedrock focuses a lot on providing the choice, but we are also focused a lot on providing a rich set of tooling for developers to build generative AI based apps. And I think increasingly that the tooling, things like RAG, things like being able to create agents that interact with other software systems, that's going to be very powerful. And at the very top, you're going to have complete set of applications, Code Whisperer being one such application where developers get ready to use code recommendations in the IDE of their choice. And you would continue to see a lot of innovations from AWS, and also more importantly rest of Amazon at the top layer, where, as I said, every company in Amazon is thinking deeply about generative AI, and I think we would see a lot of very interesting applications emerge for customers soon.
Yeah, and I'm glad you brought up agents because I did actually plan to ask you about that. You brought it up a couple times. Any other thoughts on agents? Because there's a group of people out there who think agents are sort of the end game, and that they're going to be the most interesting. I'm not sure I agree with it. I think it's both. I think agents are really important, but any particular thoughts on that? Just is someone who has his finger on the pulse of the market here?
I think agents are very powerful, but I think a lot of it goes to the discussion we had on chatbots and kind of that pyramid of opportunities. I think agents are still on the top, where kind of the use cases are going to be limited for now, but over time we expect that pyramid to invert, and you would see more number of use cases happen with agents, particularly as models become more capable of interacting with multiple software systems independently without hallucinating as much. So today, the agents are great, but I think their ability to deal with a lot of software systems, and particularly thousands of APIs, I think they run into issues, which is kind of the core kind of bottleneck for agents today. Again, this could be an entirely separate podcast, and I don't want to talk too much.
Yeah, and maybe we should. And I think it would be fair to do that in the future when the agent
Yeah.
space is a little bit more developed. But Atul Deo, this has been amazing. Everybody check out Amazon Bedrock. Anything else you want to direct people towards?
No, that's it. I think Bedrock is generally available. We're very excited to see customers use it, and would love to see you develop very cool applications on top of it.
All right. Well, thanks for joining us today and like talking for so long, sharing so much. This has been great.
Thank you. Same here.